Hello and welcome to Scala tutorials at Learning Journal. Scala is a hybrid language. It supports object-oriented programming and also supports functional programming paradigm. But a data engineer or a data scientist is more inclined towards using Scala as a functional programming language. And hence, the tutorial will be leaning towards functional programming using Scala. So, before we start learning Scala language elements, it is a good idea to cover the elements of functional programming. So in this video, I will talk about elements of functional programming and try to build a high-level concept. So let's start. Who coined the term functional programming? John Backus. He was the first person to use the term functional programming in 1977. He used this term in his A.M. Turing Award lecture. If you are interested, I have a link to his paper in the description. What is functional programming? There are disagreements about the answer to this question, but at the simplest premise, here is the definition. Functional programming is a way of writing software applications using only pure functions and immutable values. What does it mean? I will explain it, but it may take some time and practice to understand the real meaning and implications of this definition. This definition is reasonably good. However, the pure function and immutable values are just two elements of functional paradigm. There are many others, and here is the list of top 10 functional programming concepts. This list covers the most frequently referred elements. A high-level understanding of all these items is essential to reason the constructs of a functional programming language. I mean, when you learn the various Scala features, you should be able to relate and justify them based on the elements listed here. This list answers another question. Why functional programming? If you understand the benefits that these 10 items bring on the table, you know the answer to this question. The greatest benefit of functional programming is that it brings a different approach and facilitates to solve your problems. By the end of this video, you will learn many of those facilities and the overall approach. When you start practicing functional programming, you will realize that the approach fits better in many scenarios. Library design and data crunching are among those problems. That's the main reason the Spark creators picked Scala to implement Spark libraries. So with the stage set, let's take these top 10 functional programming elements one by one. The first item on this list is a pure function. So, what is a pure function? Let me ask you a simple question. What is a function? Let's take the definition of a function from the mathematics, because all mathematical functions are always pure. A function relates an input to an output. So, there are three main parts: the input, the relationship, and the output. Here is an example. The input is 4 and the output is 2. Where is the relationship? The actual code for sqrt function is the relationship, and that's a critical part because it is a relationship that determines the output based on the input. There are three observations about this mathematical function. The input solely determines the output. I mean, there is no other thing like a global variable or the content of a file or input from the console that determines the output. It's only the input parameter value, nothing else. No matter how many times or where do you invoke this function, as long as the input parameter value is same, you are going to get the same output. That's the first feature of a pure function. The function doesn't change its input. In some of the programming languages, you might have heard about the call by value or call by reference. All that confusion is out of the scope from a pure functions standpoint, because it guarantees that input value remains unchanged. It never modifies the input value. That's the second quality of a pure function. The function doesn't do anything else except computing the output. I mean, it doesn't read anything from a file or console. It doesn't print anything on the console or write some data to a file. It doesn't read or modify a global variable or, for that matter, anything outside the function. In fact, it doesn't perform any I/O. A pure function is similar to a special purpose machine. Takes the input, computes the output, returns it, and that's all. No other work. If it does anything else that impacts the outside world or is visible to the outside world, we call it a side effect of the function. A side effect is like doing something other than your primary purpose, right? So a function is pure if it is free from side effects. That's the third quality. That's all. If a function qualifies on these three conditions, it is a pure function. Is there an easy method to validate the purity of a function? Yes, test it for the referential transparency. Okay, but what is referential transparency? A function is said to be referentially transparent if we can replace it with the corresponding value without changing the program's behavior. So, can you replace all references of math.sqrt with its corresponding value 2 in your code? Answer is obviously yes. If we know that input value is 4, we can replace sqrt with 2. Will it change the behavior of your program? The answer is obviously no. So the sqrt is a pure function because we can change its references with the output value as long as input value is same. Let me give you another example. I haven't covered anything about Scala yet, but don't get trapped into the syntax. We will learn the syntactical part of Scala as we progress. But for now, just focus on the concept. So, consider that g is a global variable. The rt is a function. That's a Scala syntax to define a function. I am using this function like this. The output of first rt call is 15 and the second rt call is 20. Can I replace all references of rt5 with 15 or 20? No, right? So, rt doesn't qualify to referential transparency. It's not a pure function as well for two reasons. First reason, the rt is dependent upon global variable g. So, the output is not solely determined by the input parameter. Second reason, it modifies an external variable, so it has a side effect. So, the referential transparency fails for this function and it's not a pure function. Great. So, we understand the pure function, side effects and referential transparency. Let me summarize a pure function. A pure function follows these rules. The output is only dependent on input parameter values. The function doesn't modify the input parameter values. The function doesn't have a side effect. Few more things. A function is referentially transparent if evaluating it gives the same value for same arguments. You can test the purity of a function using referential transparency. Now, let's come to the benefits. Why pure functions? Pure functions encourage safe ways of programming. I think you already agree with this statement because side effects are surprising for everyone except the original coder. Pure functions are small, precise, simple, safe, and easy to reuse because you know that they take input and give output based on the input values. They don't do anything else. They don't surprise you. Pure functions are more composable or modular. It is very common in functional programming to combine many functions into a simple solution. For example, you will often see functional programming code written as a chain of function calls, like this. You can do this with non-pure functions as well, but it is easy for pure functions because they don't have side effects and output depends only on input values. We refer this capability as functional composition, and you can compose more confidently if you know that there are no side effects. Pure functions are easy to test. I think you will agree with this as well. Since there are no side effects and the output only depends on input, your test cases are straightforward. You just pass the known value and assert for the expected value. Whereas simulating the side effect is a real challenge for testing. For example, you have two functions. The first function is not pure, so it prints hello world on the console. The second function is pure, so it doesn't print anything on the console but returns hello world. You can quickly assert the return value. However, asserting the console output will be a complex thing. Pure functions are memoizable. The memoization is nothing but caching of deterministic functions. If you know that your function is pure and you will need the results again, you can cache the output. Or your compiler can also do that as an optimization. But if you have side effects, you can't cache the results for later use. Pure functions can be lazy. This one is a big advantage, and we have listed it as a separate topic in our top 10 list. I'll cover it later when we reach to the laziness. Great. Let's move on to the next item. First class functions and higher order functions. What is a first class function? If you can treat a function as a value, it is a first class function. That's a simple definition, but what does it mean? That means you should be able to do everything with the function that you can do with a value. You can assign a value to a variable, so you should be able to assign a function to a variable. You can pass a value to a function as an argument, right? So you should be able to pass a function as well. You can return a value from a function, so you should be able to return a function also. If you can do these three things with a function, it's a first class function. In Scala, all functions are first class functions by default. That's a feature of Scala. You don't need to test if your function is a first class or not. We will see some examples, but before that, let me cover the next jargon. What is a higher order function? The function that does at least one of the following is a higher order function. Takes one or more functions as arguments. Returns a function as its result. So, let's assume I have a function f1. By default, f1 is a first class function. So I should be able to do these three things with f1, right? Now, let's assume I have another function f2. If f2 can take f1 as an argument, f2 is a higher order function, right? That's what the definition says. Now let's take a working example. You can ignore the syntax for now and just focus on the concept. So, this is my function. It takes an integer as an input and returns a value by doubling it. It's a first class function by default. Now let's see how can we apply these three things to this function. Let's assign it to a variable. Done. Now you can use variable d as it is a function. Next one is to pass it to another function as an argument. Let me show you. So, R is a Scala collection of type range. You can take a look at the documentation. There are many methods defined on the range collection. One of them is a map function. It takes a function as an argument, then it applies the function to all elements of the range. So, if we pass the doubler function here, it should double each of the elements. Let's try. Look, every item is double. Since we assigned the doubler function to a variable, you should have been able to pass the variable as well. Both of these lines have the same meaning. So, we applied both of these things on our function, right? And you must have realized that the map function is a higher order function because it took a function as an argument. Finally, we need an example of returning a function. But before we move further, let me quickly summarize. All functions in Scala are first class. So, you can do following things with a function in Scala. Assign it to a variable. Pass it as an argument to other functions. Return it as a value from other functions. A function that does at least one of the following is a higher order function. Takes one or more functions as arguments. Returns a function as its result. Scala allows you to create higher order functions. Good. We have seen everything in action except an example of a function returning another function. I will come to that, but let me cover another jargon. Anonymous function. What is an anonymous function? A standard function has a name, a list of parameters, a return type, and a body, right? If you don't give a name to a function, it's an anonymous function. Simple, isn't it? Let me show you one simple example. So, this is a syntax for the anonymous function. List of parameters, body, and return type. That's it. No name. The return type is optional. So, if you leave it, Scala will automatically infer it. If you compare the syntax for an anonymous Scala function with a standard Scala function, you may notice the difference here. A normal function uses equal to symbol before the body, whereas an anonymous function uses this symbol. This entire thing has another term, a function literal, and this syntax is known as function literal syntax. Okay. So you might be wondering how to call this function if it doesn't have a name. Well, you can assign it to a variable. And then you can call it using the variable. But that's not the real purpose of an anonymous function. If we wanted to assign it to a variable and call it later, why do we create an anonymous function? What's wrong with the named function, right? I mean, a named function or an anonymous function assigned to a variable is the almost same thing. So the big question is this: what is the purpose of an anonymous function? Why would you want to create an anonymous function? Well, the answer is simple. There might be scenarios where you want to create an inline function for a one-time usage, and giving them a name doesn't make any sense because you don't want to use them anywhere else. In those cases, creating an anonymous function is quite convenient. Let me show you an example. I am going to create a function that returns a function. Pay a little attention to the syntax because the syntax for creating a function that returns another function is little tricky. So, I am creating a function getOps. It takes a parameter of type int. In a standard function, you should define the return type after a colon and then an equal to symbol and finally the body, right? I am skipping the colon and the return type for simplicity. I can skip that because Scala will infer the return type automatically. Place an equal to symbol and use the function literal syntax. We used function literal syntax for creating an anonymous function, right? I am using similar thing here. Parameter list and the body separated by this symbol. If you are still not clear about the syntax, just ignore it, because we will be doing a lot of these things as we progress with the tutorial. Now let me create two local functions, doubler and tripler. If the input parameter c is a positive value, return doubler, else return tripler. Simple, isn't it? The getOps function takes an integer c. If the value of c is positive, it returns a doubler, else it returns a tripler. Let's test it. What do you think? What should happen here? The getOps is a higher order function and it returns a tripler function. The map is another higher order function which takes the tripler function and applies to all elements of the range. Working. All items are triple now. Let me try with a positive value. It's double as expected. But the point that I was trying to explain was this. Why would you want to create an anonymous function? Let me explain that now. Just look at the code of getOps function. I can write it like this. Does it look little straightforward and clean than the earlier version? Instead of defining these two functions and then returning them later, I simply use anonymous function body right at the place where it is needed. This kind of code is more convenient to write and easy to understand. You may have several such scenarios that you just want to create a function and use it right there. Anonymous functions are there to allow you to do that. So now you understand the first class function, higher order function, anonymous function and a function literal. The function literal might be little confusing, but you can plainly say that the signature and body of a function code is a function literal. That's it. Okay. Now you must be expecting to understand the benefits. What is the purpose of all this? I mean, we can pass functions and return them. But why would I want to do that? I'm more than happy to use object-oriented techniques. What is so great about the idea of passing around functions, right? Let me explain. Abstraction is the main benefit of higher order functions. Abstraction makes the application easily extendable. When developing with a higher level of abstraction, you communicate the behavior and less the implementation. Let me show you a simple example. Let's say you have an array of customers. Now you want to send a greeting message to all of these clients. The most obvious method to do this is a loop. It may be something like this, right? It's a quite simple code. For each customer, we want to call a function println. Instead of println, you may have some other function. For example, payment reminder. Here is my dummy function for payment reminder. The new loop looks like this. So, what are we doing? In fact, we want to say this. For each customer, remind payment. If you design this using a higher order function, your final code will look like this. This line does the same thing, but I have abstracted the implementation details behind a higher order function. For each is a higher order function and it takes two parameters. I will show you the code in a minute, but let me make some points before we look at the code. This kind of programming approach is more precise, easy to understand, and more reusable. I mean, I can reuse the same function to send payments to all my vendors. Or I can use the same function to invite all my customers for a function. Okay, now let's look at the code. The for each function takes two parameters. The first parameter is an array of strings. The second parameter is a function. We loop through the array and call the function for each element. That's it. In fact, Scala provides this kind of iterator method for every collection. So you don't need to implement a for each function. Let me show you. It's like take customers and for each customer remind payment. We will learn more about iterators later in the tutorial. Great. So we learned first class functions, higher order functions and their benefits. I intend to cover all of these items. However, including all of them in a single video makes it too lengthy and tedious. So, I am closing this video here and will cover few more topics in part 2 of this video. Thank you very much for watching Learning Journal. Keep learning and keep growing.